Hi, Ben with Novelix Stereophonic, and needless to say, I've got something pretty special in front of us here today. This is most of a Braun Wandanlage wall system. This was designed by Dieter Rams, the famous German designer in the 1960s, and it would have been incorporated into the Vitzu shelf system. The system consisted of the TS45 receiver, LS450 speakers, PCS5 turntable, and what we don't have here, which is the TG60 reel-to-reel. I currently have possession of this system because I was commissioned to repair it. I started out with an on-site service call, and during the diagnostic I found that the turntable was spinning excessively fast and the rest of the system just sounded really bad and it needed a lot of work. So I took the units back to my shop and I just completed a full service on everything, and they're finally ready to get wrapped up and reinstalled on site. In this video, I'm going to go over the diagnostic, service, and restoration process of this entire set. So if you're interested in learning a little bit more about what makes one of these tick, stay tuned and we'll dive right in. In the field, I diagnosed the speaker having a bad tweeter. I don't know if the tweeter itself is bad or if there's a bad connection, but there's no sound coming from the tweeter.
On average, the situation's worst in poor countries. Only about 1 in 3 of them report having hypertension medications easily available in pharmacies or clinics.
So right now I'm feeding in a 1 kilohertz test signal, but all of the sound is coming out of the woofer. If I take the frequency and raise it up, we'll hear the signal start to die out as the crossover is cutting the frequencies to the woofer, and by the time I'm at 8 or 9 kilohertz, there's just no sound coming out. So something's either wrong with the connections on the tweeter, or the tweeter itself is bad. But the problem is this cabinet is nearly impossible to get into. The rear panel of the L450 is designed to be removable. We have all these screws along the edge and 2 in the middle, but they use some sort of gray caulking material around the outside edge, and over time it's turned rock solid, and it's going to be extremely difficult to remove this panel without damaging it. Here's the second speaker, and this one seems fine. Here's my 1 kilohertz test tone. As I increase it, instead of rolling off, the higher frequencies are handed over to the tweeter, and now we're at 10 kilohertz. So this speaker's working fine. Here's a look at the TS45. This is basically a stereo receiver. It's just in kind of an unconventional package. So this has tuners, a preamp with a phono stage, and a power amplifier to drive speakers. Now in the field, I diagnosed this as having one bad channel. One channel is weak and distorted. And on FM, I didn't get a stereo indicator. And as I was going around the dial, it looks like the dial string fell off of the tuning knob here. So definitely got some work to do there. So let's open this thing up and see what it looks like inside. Let's get some light on the situation. Okay, so on a quick look in here, we have a power amplifier up here with the driver board. This has got to be all power supply related. This is the back of the selector switch here. My guess is this board is a Phono preamp. Line stage, this is where all the tone control is. And all of this is going to be tuner related. One channel of this device is definitely quieter than the other, and that's something that needs to be addressed. Luckily, it was pretty easy to separate the preamp from the power amp in this unit because everything is designed in a modular fashion with socketed interlink cables. On the test equipment up here, we're looking at the output of the preamp, and one channel is definitely lower in amplitude than the other. So I'm pretty sure I have this isolated to one single board. I just need to extract that board and see if I can find the issue. This is the board that I suspect, but in order to see everything clearly, I want to pull it out, and for that I need to remove the knobs. During the initial testing of this unit, the dial string for the FM section got dislocated from its normal path, and the tuning wheel is no longer adjusting the FM band, so that's something I'll have to look at later. But the problem at hand here is getting these nuts removed so that I can pull out that preamp board. There are many more suspect components on that board, but those were the two that stood out as really bad. So with the replacement parts in, let's see if we have any improvement. I mean, it's looking better. Maybe my balance control isn't centered. Let me check here. Oh. Here's volume. Let's put this all the way to maximum. Next one is balance. That's closer to center. So I think that did fix that main issue. Let's see how the square wave response looks. Let's check the tone controls. I really don't have a lot of action in the bass control on the upward portion. I can attenuate the bass here, but it doesn't seem to operate past center. So I'm not sure if that's normal or not, but in any case, both channels are now equal. So that was the fundamental issue with it. So it does look like those caps were the root cause of the issue here, and the issue is now resolved, but as we saw, there's a lot of suspect parts on this board of the same type that really should get replaced before this thing gets put back together. Unfortunately, it looks like the dial string actually snapped in half here, so this whole string will need to get replaced. So what I want to do is maintain the information I have here about how it was routed, so I need to tape this into place so that when I get the replacement dial string, that I know exactly how to put it back in. A friend of mine had some scrap dial cord laying around. I was able to replace the broken section of cord on the FM section and restore the function of the front end adjustment again. I just flipped this down to check the motion of the dial, and unfortunately I didn't put enough turns around the wheel here. So what happens is when I get down to this end, I'm physically limited here. I think I needed one extra turn on here, so I can't go above 106 megahertz. So I've got to restring this dial again, unfortunately. With the dial string fully resolved, I can now move on to creating a parts list to get this unit fully rebuilt. I'm really starting to like this design. It's built in a modular way, so I was able to completely extract the power amplifier module by removing the speaker output plug and the connection to the power supply. This is where the preamp board socket's in, so that's really handy that I can pull the power amp out and service it standalone. This is the power supply. It's pretty simple, just a handful of caps and diodes. MPX board for the tuner that's removable. And then the other boards that are not removable have enough lead length on them that I can unscrew the board from the chassis and get around to the back side. So overall, this is going to be pretty easy to work on. I've got a parts list put together for everything that I'm going to need to finish out this project. So I'm going to get that ordered. And while I'm waiting for those parts to come in, I'm going to jump back on the speakers. I've been trying to extract the back panel from this defective speaker for the better part of a week now. I came up with this contraption to suspend the back panel
and my hope was that with some gravity and some heat, I'd be able to extract this panel from the back of the speaker, but it didn't work. I tried everything, heating up the adhesive, using putty knives, but I couldn't come up with anything that would get the panel off without destroying it or causing damage to the edge of the cabinet itself. So what I eventually decided to do was mark the location of the tweeter, because my main thing was I need to figure out if this tweeter is bad or not. So I marked the location and drilled out a slug with the hole saw, and I was able to extract the driver. This is what the tweeter itself looks like. Let's see if this voice coil is good. Yeah, I have about 4 ohms of resistance there. That coil is intact. So the next thing will be to test and see if this makes sound. If this driver actually works, that means there's probably a failed capacitor or something in the crossover circuit. I'm going to feed a 3 kilohertz signal from my signal generator and just raise the amplitude on the amplifier. We'll see if this makes any sound. Nice, that thing sounds nice and strong. Let's do a quick frequency sweep. Yeah, that sounds like it's working just fine, which is actually good news. That means there's probably some repairable component inside of the cabinet or a loose connection somewhere. If the tweeter was bad, I don't know what I would do. I'd probably have to source a new speaker. Here's the slug from the hole saw. Eventually I'll be able to put this back in here and seal this panel back up. I've already pulled some of the insulation. I'm going to pull out a little bit more and see if I can expose the crossover. I was able to extract more of the insulation, and I did expose the woofer, but it looks like the crossover components are on the other side of the speaker down lower in the cabinet. So I think it's inevitable at this point. I'm going to need to figure out how to get this rear panel off. So this is what I came up with. This is the hole for wall mounting the speaker. I drilled through it, and I have a bolt in here with a nut and a washer that's held up against this side. And then I have a hockey puck in here that is sitting on the side frame. And basically, as I rotate this bolt, it's pushing this corner of the panel out with respect to the framing inside of here. So I think as I slowly ratchet this up, I've got a 7/16 wrench inside of here holding that nut and washer up against the panel. As I slowly crank this, I should be able to apply heat on this edge, and once I pop this corner, I think with heat I can pry the rest of the panel up. So that's the idea anyways. We'll see how it goes. I did eventually gain access to the inside of the cabinet, but as you can see, I needed to destroy the entire back panel to do that. I did remove this nice name badge, so I'll be constructing a reproduction panel, and that will be going on the back. Just to describe the process that I went through, this is where I had drilled through and had that long bolt coming through with the nut and the washer pushing up on the back panel. I applied heat around here, putty knives, tried to get that loosened up, but no matter what I did, it just would not budge. In fact, it sheared off the bolt that I was using completely, so it just wasn't happening. So what I found is that the gasketing material created a stronger bond than the fibers of the wood pieces themselves. So when I ended up prying these panels up, it wasn't giving at the gasket level, it was actually either breaking the fiberboard of the back panel or peeling the wood away from the frame. That's how strong that material was. So there was no way I was going to get that back panel off without destroying it. So now that I have it open, I want to look at these crossover components and see if any of these have failed, which would cause the tweeter to stop making sound. That capacitor is showing open, and that's directly on the positive lead for the tweeter. So that's probably the culprit right there. Let's take a look at this other pair of electrolytics. Showing open again. It may be across a coil and it may be fooling the tester. So I'll have to desolder some of these and double check. Let's see what this one does. They all show open. All right, I need to desolder these and retest. Yep, still showing open. The cap's bad. I pulled one leg of each of the remaining capacitors and tested them as well, and they're also bad. So unfortunately what this means is that even though the other speaker is currently producing sound, I need to remove the back panel and do the same maintenance because it has the same parts and that speaker is eventually going to experience the same failure. So I'm going to put together a parts list, and while I'm waiting for those parts to come in, I'm going to go ahead and start rebuilding the receiver. All of my parts arrived. I'm going to get started with the power supply and the power amplifier first. The amplifier board for this unit has some sort of strange white corrosion on it that's eating the traces. So this is something that I need to address now so it doesn't become an issue in the future. So I'm going to go ahead and clean all of this white material off and then strip these traces back down to copper and reflow them to protect them. So that took quite a bit of time, but it's now done. I've got all of that corrosive material removed, all the traces have been prepped and protected, and now I can move on with rebuilding this board. I've got the power supply and amplifier modules rebuilt. The original main filter capacitors in here are these stud mount types, and you can see that there was a lot of venting happening here. These caps were definitely on their way out. In circuit, they were just paralleled together, probably a size constraint thing. But modern day parts are much smaller, so I was able to get an equivalent value in a single capacitor, and I just mounted it in a clip so that I didn't need to drill any additional holes in the chassis. I also replaced the power cord. The original cord was quite short and it wasn't reaching all the way down the wall to the outlet, so I've replaced that with a nice long 10-foot plus extension cord here. This unit is equipped with a multi-region transformer, so it can be switched depending on which country you're in. Right now it's set at 115 volts, which is fine, but a lot of times the mains in Manhattan goes above 125 volts, so I'm going to go ahead and take advantage of this 127 volt setting just to give it a little extra safety margin. Having these two modules out gave me a little bit more space to work, so I took advantage of that and redid the Phono board, which will mount back in here, but it was easier to work on when I had the space to pull it out and manipulate it. So that's done. Let me go ahead and load these modules back in place. The unit is mostly reassembled, power supplies in, amp modules in, phono stages in. I did a few caps on this removable MPX board. This is for the stereo decoder. I haven't tested this yet because the dial string broke. So this thing's about halfway done, but it's all put back together. So I'm going to go ahead and do another baseline test, see where things stand, make sure that the amplifier is working well, and we'll see if the tuner can decode stereo in its current state. As part of the amplifier service, I replaced the aging bias and DC balance trimmers. I'm set up to measure bias right now by removing the fuses and inserting DC ammeters in series with the fuse holders. I'm looking for about 40 to 50 milliamps. It looks like this channel is right on. I'm going to just make a minor adjustment to the other channel to get it to the same level. This device is rated at about 12 watts per channel into 4 ohms. That's the nominal impedance of the speakers in this system. So I have my PA81 set up with a 4 ohm dummy load. Let's see how much power it actually makes. Right now I'm feeding in a sine wave and I'm just going to ramp it up until we see clipping. I'm already starting to see it on the red waveform here a little bit. The top of the waveform is getting flat. Let's ramp it up until the yellow one clips. Right about there. And if we look up here, we're right around that 12 watt mark. So it looks like the amplifier section is working properly, but the channel indicated in red here is out of balance. This is a capacitor coupled amplifier stage with a single rail power supply. So we need to adjust this balance trimmer to basically center the output in between the power supply rail and ground. So as I spin this control, we should see the clipping shift from one side to the other. So we're balanced right about there. Let's bring the yellow channel back in and see how they compare. So it looks like the yellow channel is able to produce just a tad more power than the channel indicated in red here on the scope, but overall they're really, really close and they're both evenly clipping. We can see that the top and the bottom of the waveform are equally rounded when we approach that clipping power. And if I get them both to where they're really nice and clean, we're looking at right around 10 watts per channel. This is looking good. I have my FM signal generator feeding a test signal into the unit, and we can actually see a sine wave on the scope and hear it here, but the waveform is all wobbly, and if I flip it into stereo, we can see the waveform change. It's almost like it's having trouble rejecting the 19 kilohertz pilot tone, but it is fundamentally decoding stereo. I can see it decoding two independent waveforms there if I feed it an L-R waveform. Stereo separation is not that great. So the tuner needs some work. It could just need some alignment, but I have a feeling that some of the aging caps in that board that I haven't done yet will contribute to this. So it'll be interesting to see if there's any change after I replace those parts. I pulled the MPX board again and I ended up replacing a bunch of leaky germanium diodes. This helped me be able to actually align the MPX properly. Once that was done, I did the dial tracking, discriminator and everything and got it all working as well as it's going to. So it still has that 19 kilohertz bleed. I tuned it out as much as possible with the 19 kilohertz trap, but there's still a little bit there. If we go into L-R, my waveforms are now a lot cleaner and balanced with one another, and the stereo separation is leaps and bounds better. So I'm really happy with how that turned out. If we look down at the stereo indicator, you can see as I toggle between stereo and mono broadcast that it picks it up. So all good there. Moving on.
Easier with qualifying savings today. Friday will bring a mix of clouds and sun, hitting a high of 56. Saturday will see some sunshine peaking.
After replacing all the suspect caps in the preamp section, the tone control circuit is working much better. If you recall before, I was able to cut the bass, but past center, it wouldn't do anything. Now with those caps replaced, I can actually boost the bass, so that's a big improvement there. Treble control is also working really nicely. If you've been enjoying the hands-on diagnostic and repair portions of this video, you might like my Patreon page. I'm building a library there of exclusive content, focusing on my day-to-day audio work at the bench, very similar to what you're seeing here. So if that sounds cool, head down to the description for a link. Now, I thought that I was completely done with this piece, but after I hooked everything up, one channel on the Phono stage was dropping, so I ended up needing to jump back into the TS45 for one more repair.
This transistor here is sitting loose in the socket. These other ones are nice and snug. So this one, as I manipulate this transistor, I can get the signal to come in and out. I cleaned the pins in the socket, but it didn't help. So what I'm going to do is actually remove the socket and solder this transistor directly to the board. Here's a look at all the parts that I replaced in the TS45 receiver, starting from worst on the left to best on the right. And this is very typical of what I see in vintage audio electronics servicing. We have parts that are completely fine, could have stayed in the unit, weren't causing any issues. We have parts that had completely failed, and then we have stuff that's kind of in the middle. So let me go over it. Starting here, this power cord was completely fine. I just needed to put on a North American plug, and for this specific use case, we needed a much longer cable, so that's why that got replaced. These ones were completely fine. In fact, some of them are good because they had already been replaced at some point in the past, but since I was already in there, these got replaced anyways. Moving over to the other side, these parts were completely bad. They were either open or very high ESR. We had a bad socket and of course a broken dial string. These parts their similar types have already failed over here and they're testing poorly. They're on their way out. Then I had some marginal diodes here that were causing the tuner to not perform properly. These parts here tested okay, but they're suspect. If we look at these main filter capacitors, there's signs of venting here, so those needed to go. These Fracco capacitors, I'm not sure of this specific type, but Fracco capacitors in general are known to just randomly short without warning, so I always like to take those out on site. And then here, these are just some trimmers for the adjustments in the power amplifier. They're a little bit corroded, and I just didn't want them to become an issue in the future. So up to this point, I've rebuilt the power supply, power amplifier. I put a new string on the FM section, serviced and aligned the tuner, serviced the preamp section, phono stage. I tightened up the nylon diffusers here so that the lights look a little bit nicer. And it's finally time to put the faceplate back on. I found an old service tag inside of this unit and thought it would be appropriate to add my sticker here as well. With the TS45 receiver fully sorted, I can jump back on the speakers. My parts have arrived for the crossover, but before I rebuild this section, I want to clean up all of this and get it prepped for the replacement rear panel. I've got all of the original fiberboard and gasketing material removed. This is now nice and smooth and ready to accept a new gasketing material. There are some voids though here, here, and a big chunk missing down here that happened during the removal, so I'm going to build this up with some JB Quickwood. I'm just manipulating this until it becomes one uniform color. That way I know the two parts have fully mixed. I find that this JB Quickwood is really easy to manipulate if you get it just a little bit wet on the surface. It's almost like working with concrete or something, and you can kind of form it exactly how you want it. So I try to get it as close to where it's going to be in the end as possible, so I don't need to do much sanding or carving after the fact. So right now I'm just wetting the putty knife and just using it to kind of form this section into a nice flat representation of where this wood used to be. Okay, all my voids are filled. I just need to wait for the epoxy to cure. After that, I'll sand and prep the surfaces, and once all the mess is done, I can go ahead and start rebuilding the crossover. The epoxy is fully cured. I'm just touching it up with a razor blade, just flattening it out. And you should be good to mount a new back panel. Before I replace the crossover components, I want to make sure I'm done with all of the messy work inside of the cabinet. This gasket here is for the tweeter that I pulled out, and it's no longer going to be effective since this edge is broken. So I need to remove this so that I can redo the seal when I put the tweeter back in so that air doesn't leak in through the tweeter junction. I must have had an issue with my tester the first time I tested these parts. Check this out. Seems fine. These capacitors all work. When I initially tested this speaker, the tweeter basically didn't work at all. So that's why I drilled that hole in the back of the cabinet to extract and test the tweeter. The tweeter tested okay, so I suspected this crossover section. My purple tester was acting up and gave me false readings, making me think that all of these capacitors were bad, when in fact they fundamentally work. They're not on value. This one, for example, is supposed to be 25 microfarad. It's measuring like 32, so the frequency response probably isn't where it's supposed to be. But the crossover should fundamentally work. I just cleaned the connections on the tweeter and reconnected it, and now it seems to be working. So right now this is 1 kilohertz. That's going to be mostly coming out of the woofer, but let me change the frequency. This is 2, 3, 4. I'm not sure if it's going to come through the mic, but I'm at 10 kilohertz and I can clearly hear it. If I take the cabinet off of the tweeter is obviously working. So I have a hunch that either something was corroded on one of the capacitor connections, because I have unsoldered and resoldered some of these parts, or the connections to the tweeter itself had become corroded. So this was misdiagnosed in the beginning, but now that I have the whole back panel removed and I'm at the crossover, I'm going to go ahead and replace those parts. Looking forward, I'm going to need to determine whether or not it's going to be worth it to open up the second cabinet to replace these crossover parts. So what I'm going to do is a before and after frequency response plot to see how much the crossover points change after I replace the caps. I tried making a plot with the analyzer connected directly to the drivers, but it didn't turn out that well just because of the nature of how woofers and tweeters function. So I'm going to connect the crossover to a dummy load instead and see if we can get a cleaner plot for comparison. So this is working much better. I have the outputs of the crossover loaded at approximately 4 ohms to simulate the drivers. The red trace here is showing the woofer. The yellow trace is showing the tweeter. If I turn on the volume here on the PA81, we can hear the sweep. The green trace here is our woofer frequency response, and the yellow trace is the tweeter. Now we can see there's not a lot of overlap, and this might be fine, but I just want to screenshot this plot so that after the capacitors I can compare it to see if it shifts the crossover point or if it flattens out the frequency response or something. So I'm going to take a screenshot of this to save for later, and I'll replace the caps and we'll repeat this plot. The original capacitors that are loaded into this cabinet are bipolar electrolytic, which are prone to drying out and failing. So I'm going to be replacing them with polypropylene film, which should last for the duration. that was really interesting. I went to put this first capacitor into place and I thought, let me put it on the underside of this red wire. This is the wire that leads to the tweeter. When I went to touch that, it just fell right out of the solder joint here. I think this is why the tweeter didn't work. I think this solder joint was cold and it broke and there was intermittent contact here. So looking back at this, I would have needed to open this cabinet anyways to access this to resolve the issue. So it wasn't a waste to remove the back panel and do all this cabinet prep. So I'm going to get that soldered back into place, and I will resolder all the other connections here just to make sure. Capacitors are all replaced. I'm going to go ahead and hook this up just like I did before, and we'll repeat that plot. I'm running the plot again, all things are equal, and overall the curves look very similar, but I need to print screen this and compare them side by side. Before is on the left, after is on the right. We can see that the shapes are very similar before and after, but the big change is the amplitude of the tweeter. So on the after, the amplitude of the tweeter has come up by about 2 dB, and now it matches the amplitude of the woofer at its peak. So this one, we're about 2 dB down with reference to the woofer with the original parts. So that's the big change here, and what this means is that now with the new capacitors, the tweeter is going to be more balanced relative to the woofer. The capacitors that were present here have almost certainly drifted, so let's take a closer look at those original caps. I drew up a quick schematic of how the capacitors work in this crossover. The 10 microfarad and 25 microfarad parts are responsible for the tweeter crossover. So those are the ones that I'm going to focus on here. The woofer had basically the same frequency response before and after, so I'm not too concerned about that 12 microfarad cap, which was this other gold-colored Rotterstein cap. So let's focus on these blue ones. I've got the 25 microfarad hooked up to my LC103 capacitor analyzer. Let's take a look at the results. I have the original 25 microfarad capacitor hooked up to the LC103 analyzer. It's set up to look at aluminum electrolytics, and I've matched the specifications that are written on the part. And we're going to be taking a look at 3 parameters: value, ESR, and leakage. Let's start out with the capacitor value. So this is supposed to be 25 microfarad. It's reading quite high at 31.3. Let's take a look at the ESR. ESR is equivalent series resistance. It's a property that electrolytics just have by nature. This looks okay. And then finally, leakage. So this part is reading bad for leakage. It's starting to come down as the capacitor forms, but this is definitely not an ideal part to leave in there. And the leakage and value being off could be contributing to why we saw that 2 dB reduction in the frequency response curve. Let's compare this to the polypropylene cap that will eventually end up in the other speaker. If I do the value check on it, 25.2, pretty darn close. Just got even closer. Let's take a look at the ESR. Should be very low on a polypropylene cap. Yeah, basically nothing. And then leakage should be near nothing on a film cap. Good. So the replacement parts are much closer to how the circuit was originally designed. Let's take a look at the 10 microfarad in the same way. So the 10 microfarad is made up of a combination of an 8 and a 2 microfarad in parallel. We're going to change this to 10 microfarad, and we're going to test at 50 volts, which is what these capacitors are rated for. All right, let's see how they do. Pretty close. And leakage. That's quite a bit of leakage in the milliamps. So that cap was leaky as well. Let's compare it to the 10 microfarad polypropylene. Again, much better part going in. As I mentioned earlier, I want to clean up all of the solder joints at these connection points here. I'm going to use a product called Mortite to replace the seal for the tweeter. A friend of mine who's a woodworker helped me reproduce the rear panels. What I did is I sent him a detailed drawing of the dimensions that I needed. I also created a little notch here for the speaker cable. It came out really nice. And then the plan was to fill all of the original holes, and then he was just going to give me a new set of holes to drill and mount this into the frame. Surprisingly, I don't know how he did this, just from looking at a picture, but he got the dimensions exact for these 6 holes. I don't need to do anything, I can use the original holes. But these ones don't quite line up. So I filled those, and I'm going to drill down so that I can get this positioned in the cabinet. And after that's complete, I'm going to mark and drill for the standoff holes. And then I'll also need to get very precise markings for the mounting holes so that when this goes on the wall, the entire system sits flush. I'd like to make sure that the speaker is serviceable long term, so for the gasketing material I'm going to use a thin compressible foam. This foam is nothing special, it's just something I picked up at the craft store. They were very limited on colors, so that's why it's purple. So that worked out great. Once all the screws are tightened in, it's going to compress that gasket, and we're going to be just about flush here on the rear panel. Now the last thing I need to do is seal up these holes so that air can't escape through where this mounts to the wall. The glue has set on my little backs here, so I just want to dry fit this one last time before I put everything together. Yeah, looks good. I was really excited to get this fully repaired speaker hooked back up to do some listening tests. And on my very first check, I noticed that something was wrong. I think one of the speakers is wired out of phase. So I'm going to do a quick demonstration and we'll listen specifically to the bass. When the announcer on this track says the system is out of phase, it actually has more bass. And when it's in phase, we're getting bass cancellation. So one of these speakers is definitely wired backwards. And the reason I know that is because when we bench tested this, the outputs were not out of phase. So let me throw on this test track and hopefully you'll be able to hear what I'm talking about.
Out of phase. In phase.
If we look at the wire for the speaker that I've been working on, it's extremely short. And the reason it's set up this way is because this speaker sits right next to the receiver, so it doesn't need to be long. But the manufacturer wouldn't necessarily have known how an end user was going to configure their specific system. So my theory is that from the factory, these would have had a full-length wire attached. And then it would have been up to the end user to shorten it as needed, depending on their system. So I think what probably happened is at some point in this thing's life, this cable got shortened and whoever did this connector accidentally put it on backwards. Now it seems like it's molded. I can't figure out how to get this apart. So since I can remove the back panel of this, I'm going to take off the back panel and I'll probably just swap the wiring inside of the cabinet and that should resolve our phase issue. I have the cabinet open back up and I'm certainly glad that I put it together the way that I did because it was so easy to get back in here. But let's test out my theory. So this wire coming in, it has a flag on it for the positive. So this is coming into the positive part of the crossover network and this is the negative or the ground side of the crossover. On the DIN connector in the receiver, the large blade is ground and the little cylindrical portion here of the DIN plug is the positive output of the power amplifier. So this thin portion of the DIN connector should correspond to this connection. If my theory is correct, this is going to be wired backwards. So let's switch this to ohms and I'm going to connect to the wire with the flag on it. If things were correct, we should have a dead short here. And we don't. We're seeing basically the DC resistance of the woofer at this point. If we move this over, this should be 0 ohms. Yes, that indicates that this plug is installed backwards. So I have two options to fix this. I can either desolder the connections down here and just flip this around, but that's not technically correct. If I can figure out how to pull this connector apart, the correct way is to reverse the wiring inside of this plug. I was able to break open this connection here and it looks like this is a twist-on type. And this was probably definitely done. Yeah, this is something that an end user would have done. This isn't a solder connection, it's just screws. And obviously these aren't marked, so it's pretty understandable how somebody could make a mistake and accidentally wire this up backwards. So I'm going to go ahead and mark one of these red, and then I will flip this around. Okay, let's check my work. So I'm connected on the red here. I've got my red marked, should correspond to this smaller plug. Almost a dead short. And if I go to the other one, it should be that 3 or 4 ohms. Okay, let's get this put back together and repeat the phase test.
In phase. Out of phase.
In the end, I decided not to fully service the second speaker. On listening test, the system sounds great. We saw that the original capacitors held up pretty well, and there wasn't a huge difference in the before and after measurements. So what I've done is I've provided the customer with the second blank that my woodworker built, along with a matched set of parts. So if that speaker ever needs to get addressed in the future, we'll have everything ready and we can address it at a future date.
Now that the receiver and the speakers are fully sorted, I can move on to the turntable.
Compared to everything else, the turntable was a walk in the park. So what I'm going to do is show you the issue that it had on site and how I resolved it. I removed the head shell and inspected the original cartridge and stylus, and the stylus was in really rough condition, so I opted to just replace the entire cartridge and recalibrate the turntable. When I arrived on site, this is how I found the unit plugged into the wall. So we have a European plug with an adapter on it, just like this. Now if we lift the platter off the turntable, we can expose the model number and specifications here. In North America, our mains frequency is 60 Hertz. So right now we're feeding a 60 Hertz frequency into a 50 Hertz motor. So let's hear what it sounds like. The solution that I'm going to implement here is from a company called KCC Scientific. And what this product is a universal voltage and frequency converter. So it uses a conventional DC power supply that can be powered from anywhere in the world. And then on this device, we select our mains voltage, which is 230 volts, and the frequency at 50 Hertz. And it has kind of a universal plug here, so I can plug the original connector right into here. Okay, let's see if we can hear the difference at 50 Hertz. One of the action items on this project was making sure everything looked as clean as possible once it was rehung on the wall. So in order to pull that off, I had to make some custom cabling. First, I made a simple dipole antenna for FM reception. This will just kind of get tucked behind the unit. I needed to make a custom extension cable for the turntable. And this one was a bit of a challenge because it needs to be shielded. Initially, I used an unshielded DIN connector and I was getting a lot of buzz. So I needed to select a cable that had a nice shield and get everything connected properly, and this ended up working really, really well. And finally, the customer wanted the ability to use an auxiliary source with the system. So what I found is there's an input on the back of the TS45 marked reserve, and that's in parallel with the tape deck. So if we just go up to the band stereo setting, we can interface any source we want with the TS45. So what I came up with for the cabling is this here. I have DIN on the TS45 side, and then for the source, I just used a 3.5mm headphone jack. And the reason I did this was to offer a bit of versatility. So this cable, as it sits, can get plugged directly into an old iPod or iPhone or something like that. If you want to interface with a modern smartphone, you can use something like this, a 3.5mm to USB-C adapter. And then if we're using a conventional source like a CD player or a streamer, we can use a 3.5mm to RCA adapter. So with this cabling, it gives them basically any option to run any source they want into the system. Now that the system is fully operational again, let's do a quick review of everything that was wrong with it. We started out with a non-functional tweeter in one of the speakers that ended up being a cold solder joint. That same speaker also had the polarity of the DIN plug reversed, meaning the system was operating out of phase. And what that would have resulted in is lack of bass and no center image in stereo listening. On the TS45, we had a broken FM dial string, and the FM performance was really poor. I tightened up the diffuser for the lamps so the lamps would look a little bit nicer. And then on the preamp side of things, the bass control didn't work in the clockwise direction. That's now resolved. I also fixed the issue with low output in one channel, and then found that bad transistor socket for the phono input. Now, with regards to the turntable, this was pretty straightforward. I used an inline 50 Hz frequency converter to correct the speed issue, and then for the worn out stylus, I just replaced the cartridge completely and recalibrated the turntable. Now, if that wasn't enough, I also had to create a reproduction rear panel for one of the speakers from scratch because it self-destructed during the diagnostic process. Then I finished up with making all of that custom cabling so everything would look nice and pretty. All in all, this was a pretty involved restoration, but I'm very happy that I took on this project. It was super rewarding to bring this system back to life. Thank you so much for coming by the channel to check out this video on the Braun wall system. Now, I'm sure you really wanted to see this thing mounted up on the wall with the reel-to-reel in its full glory, but we're gonna have to save that for a separate video. So I invite you to like and subscribe, hit that notification bell so that I can let you know when the next video drops. And if you want to show some support to the channel, I have YouTube membership. You can also check out that Patreon link in the description. Thanks again. We'll catch you on the next one.